Okay, hello. So now will be a bit longer probably. What I'm gonna present you is the Java persistent API that we are using. This is a very powerful technology, quite complex, that you can use with different flavors. You can make the decisions about how to use it. You can use it in different ways. So what I suggest, so this is the documentation that you can find online. This is official documentation by Oracle, but you can find a lot of tutorials about it. But what I suggest is that which I'm gonna do is that I'm gonna show you the the most relevant concepts that you need to learn by showing how they are implemented in our code. So this is, at the same time, it helps you because then if you need to understand something, you can see, you know where to look for examples, and then you can read the documentation and you can start learning about it. Okay, so let's do it. Oh, and another thing that may be relevant is that when you have used this kind of technologies, sometimes internally from the team decides how to use this. And then afterwards, people basically, if there's no reason, if they do not realize there's a reason to change it, they keep following the same rules, and so they keep doing it the same way. So what I suggest is that for your code, follow the same strategies, the same decisions we made in terms of how to use the Java persistence API in our code. Okay, so let's go for this. The first thing I want to show you is the structure. So what happens here? You want to create to define classes that actually are persistent in the database. So you need to deal with the object relational mapper, which actually JPA is, that basically maps this to the database. Okay. What happens with this technology is that more and more you can abstract the database structure. So we'll see that by default they consider, or by convention, they take several decisions that if you agree with them, we don't need to write so many code, and it seems that you are just writing like Java. We'll find in our code that sometimes, but I'm going to tell that sometimes we decide not to follow the conventions, or just you add more things, and then you use a lot of annotations to represent it. Okay? So let's start. So the first thing I want to show is the class question. Okay? So it's a class, a Java class that we'll work with. So you have attributes, integer, ID, key, content, title, so on. Okay? But if you want to say that this is a persistent class, you need to add this annotation. Okay? At entity. And this is enough. If you don't need to put the table annotation. So by convention, if you just have entity, the runtime is going to create a database, and in the database is going to create a table in the database with the name question. But if you don't like the name question, then you can define here this annotation table and say what should be the name of the table. Okay? In this case, we even add more and add an index. So we create an index where I use the column list key. Okay? Right? So, and this applies for every attribute. So if you say nothing, the attribute will be persistent. Okay? But of course, I can just, for instance, for this key attribute, I say that I add the information that is unique and cannot have a null value, which actually applies to a primary key that afterwards you use here as an index. Okay? You can have keys that are automatic generated, so you don't, that when they are inserted in the instance are inserted database, so the system generates a value, a unique value for you. That's the case of this integer ID. And so I have this annotation, ID, and I can even say what is the generation policy. So these generation policies vary if they are unique in terms of the table or in terms of all the instances, so you can see which one, each one is more adequate for your problem. Another thing that you need to know is that how are the names converted from the class to the database? Usually what they do by convention is that they use, so when you write in the class, use camel notation, like this one, and they convert into snake notation, or snake case, like this one. So camel case to snake case, okay? So, which means that this is basically irrelevant here because is what they automatically generate there. Note that that's not the question, the case here in this, because we have question and we decide the table is questions. Okay? And then you have another attribute that you may associate with the notation, saying that it has an integer default 0, so it is initialized in the database with an integer 0. Okay? And you have, for instance, this one that is enumerate. So this simplifies you in terms of converting strings. So in the database is a string, but you have the serialize and deserialization of the object from the database, of the information from the database to memory. They just convert to the right enumerate type. Okay? Which is good. Now we move to relationship between classes. Okay? So what I have here, if you see, the question has several relationships. Is a one-to-one relationship with image, and I represented it here. I will talk about this later. Then we have one-to-many with options. Yes, my question has several options, as one question has one image. Then I have one-to-many with quiz question and many-to-many with topics, which means that a topic can be in several questions and a question can have several topics, okay? And I have a many-to-one to course. Why? Because several questions are in one course. So let's analyze these relationships between entities. So let's go to the first one. You see that is mapped by question. So it's expecting to have question on the other side. So we have class question, and I have here image. So let's look at the class image. Okay. So image is an entity, defines a table images, and then I will see that I have question here. So it's mapped by question. So it's a one-to-one relationship between image and question. And then I have, so is here one-to-one. But here I have something new that says join column. And basically this join column says that the foreign key is in image. So image will have a foreign key which is question ID to the identification of question. Okay? So that's this join column is the way you express the foreign keys. So the same applies to the one-to-many relation between entity option. So you have is mapped by question. It's gonna tell me that the foreign key is in option that refers to the question. So let's see if that's true. We go there and we'll see that here you have a many-to-one and then you have a join column question ID. Look, is the foreign key here. Good? So it's basically the same. Good? So another thing here is that now to observe something that it says eager here. So the fetch type. So what is the fetch type? Okay, the fetch type is when you basically read one course to memory, by omission, all its options are copied to memory as well. So this is something that is useful from the performance point of view. We'll call these, I probably will talk about this later, it's called round trips to the database. So I'm reducing the number of round trips to the database. So when I read an entity, when I read a course, I don't need to do other query to 4 queries to the database for each one of the options. I just bring them here. Okay? So it's eager, right? If I go to the other side, to the option, I see that the option is lazy. What does it mean? It means that when I load an option to the database, I do not necessarily load its question. This is a strategy that you need to follow because you need to have an idea about how your structures are related to avoid that when you load something from the database, you load the complete database because of these relations. Okay? So usually what you decide is that it's like an aggregate in an aggregation in sense that if you load the head of the aggregation, we load all the elements that are part of it. Okay? But if you load one element, you don't need to load the other one, except if you just access it. Okay? So the point here is, if I just load an option to memory, when do I load the question? When in my code, I just do get question. Okay? And then the JPA will do a query to the database to get the question. Another thing that I want you to see is this cascade type. Why is this cascade type relevant? What I'm saying here is that when I create a question, I automatically and associate to this question several options. The options are created as well. And the cascade type, when is all, this applies to create, delete, to several operations that we can see in the documentation. So this simplifies a little bit the number, as we'll see in another video, the number of save operations I need to do. Okay? In that case, I just create a question with these options. I do save question, and it automatically also saves its options. Okay? So I think that basically is the most important thing you need to know now to start working on this. Oh, just a last thing. If you want to have in a persistent class attributes that are transient, you have an annotation called transient. Okay? And they are not mapped to the database. So by omission or by default, all attributes are persistent in an entity class. Okay, so good work, and see you in a while with more about JPA.